All right, sorry for the audio. Thank you for joining us. This is an abbreviated session that we have run in Cisco Live before, but it's really focused on 5 important tools to level up your automation game. Kareem and I have been talking quite a bit about network automation in very small pieces, maybe only Ansible, maybe only Terraform, but this is a larger session on how you can bring all those things together to bring your automation skills to the next level. I'd like to introduce myself. I'm Quinn Snyder. I'm a senior technical advocate with Cisco Learning and Certifications. But before that, I did a lot of DevNet automation and things like that, and that's how I got to know Kareem.
And hey, everyone, good morning. I'm Kareem Iskander. I lead technical advocacy for Cisco Learning and Certification, and we have a fun session for you. We just show of hands here. Who's done something with DevNet or some automation in their day-to-day and familiar with automation? A little bit? Okay, so in this session, what we're gonna do is we're gonna give you a quick introduction. We're gonna cover the building blocks to automation, but we're gonna up-level it. So we're gonna do a scenario between what we actually have been teaching you and what we've been talking about at events and what we're talking about from automation perspective. But then we're gonna give you practical examples of what do you actually do with all of this when you go out and automate your network in the real world, and what kind of practical examples that you use. And so we're gonna cover Git, we're gonna go through Bash, we're gonna talk about Vault, we're gonna look at how you can use infrastructure as code, and then we're gonna finally cover containers. So it's a lot of information. It's 30 minutes. The great part about this session is everything that we're going to talk to you about today, all the training, all the hands-on portions is available on Cisco U. So you can, when we have in the slides QR code that would take you to the tutorials that will show you how to learn this, and you can take this at home. So just follow along with us. Easy session. If you have any questions, raise your hand. We're happy to answer it, okay? But before we get started, this is a real conversation that happened between two jabronis at work where, we were not in a data center. My camel was not there and his bike was not there, but we were talking about automation, and we were talking about what is it that we need to know in order to up-level our automation skills. And so when you first look at introduction to Git and you get started with Git, we've been talking to you about Git. If you're familiar with Git, this is what we've been talking to you for years around branching your main, going out and living in the circle where you do a branch and then git add, git commit, and then you work in your code, git add and git commit. So this is like just the building block of Git. But chances are, if you are out there and collaborating with a group of automation engineers, you're not only going to do this, you're going to actually up-level that and you're going to need to know more than this. And so, we talked about Git pull requests, we talked about logs, push, branches. If you have done any Git or any work with Git, you should know this. This is something that you're very familiar with. But then when you go out there in the real world, you're going to have interactions with other developers that are going to potentially have way too many commits to your repo, to the main repo. Maybe you're in the integration manager, you're responsible for an automation project, and you're collaborating with five different developers working on a Meraki automation, for instance, right? And they decide to go in and do a bunch of commits to their branches. They have messages in their commit messages that are not great, and you need to be able to take that and make it production ready. And so this is where interactive rebase, something that you really need to understand and know to up-level your Git skills. And so if we look at interactive rebase, I want you to think of interactive rebase as this Swiss Army knife of Git. And it allows you to do things like change commit messages, delete commits, reorder commits. Maybe you have you've committed so many times on a feature branch that you need to combine all these commits together. Or potentially you have one giant commit that you need to split and then take that, split it into two, and start a new feature branch from it. So the interactive rebase is kind of your tool, the Swiss Army tool that's in your tool belt that allows you to do all of this. And so let's look at how this use case and how we can leverage interactive rebase in this. So think about this. You're working on a feature branch and you're expanded your Meraki to expand your Meraki automation script, right? You've been making commits every function you write. You are ready to merge into main, and you realize two things. You've overcommitted, and your commit message aren't really cutting it, where you've messed up, and the integration manager is going to essentially reject that pull request that you've made. And so how do you do interactive rebase? First of all, you got to decide and you got to learn and understand how Git head works. So you take the head, you find out which commit, and you count from the head 1 being the latest commit, the very first commit on top of your log, and then you count down to how many, and this would give you essentially the which commit you can access. So let's say I'm trying to access head 3, for instance, right? What I could do is I could say just give me head 3, so git rebase I-I, which stands for interactive, and then I could pick head 2. Head 2 would give me access to head 1, to the first commit and the second commit, so the latest commit and the one after that. If I want head 3, it will give me access to the first and second and third. So you got to decide which commits you want to do something to. And then determine the action. Once we do that, Git is going to pull up a list of potential words that you can use in order to take action on these commits. And then finally, you can make changes based on what you're after. And then you can look at your changes by doing git log. And then I really like this flag right here, -- one line, and when you're doing log, as it gives you a really nice concise message in your terminal to see what you've done, okay? So let's look at real quick here how you could do this. So I'm doing a git log -- one line. I'm looking at these commits, and I've realized that, hey, I have made so many commits that I need to get rid of some. So I'm gonna go ahead and access this head right here. So I need to get rid of this commit. I don't need it, right? So I can access 2, git 2, or I could go git 3, it doesn't matter. So in this case, I'm gonna go head 3. So it gave me access, if you notice on top here, the first 3 commits. And then it gave me a keyword here of all the things I could do. So in this case, I wanna squash or get rid of this. So I've changed that keyword to squash. Git told me now I have 2 different commit messages, which one you would like to keep. And I can delete one and then save this. This is all edited in VI, so it's all in your terminal or whatever you're comfortable using. Once that's done, I can go ahead and do git log -- one line again, and you can see how here I cleared up my commit messages. And so you got to be mindful when you're working in production that all of the commits that you're going to be working in the feature branch are going to take place once you merge it into main. And so if you're sharing this library out there, or if this is something that you're working with your customer on and you're pushing out, you got to make sure that they know the history of that repository, and you got to keep your Git clean. The other tool that you really need to understand, and I can't tell you how many times we work together, and he's an integration manager for a project, and I screw up my commit and I send it over to him, and he cusses me out. He's like, dude, now I have to do cherry picking. And so cherry picking is a really, really useful tool in your toolbar that you should learn. And are you guys familiar with the term cherry picking? What does that mean? Okay, cherry picking in English is basically going in and specifically picking something from a bunch of things and taking it out. And so that's what it means. So it's exactly that in Git. So think about this use case. You're working on the feature branch to expand your Meraki site automation. You've made commits on the feature branch. You notice that you're working in the main branch, but these commits don't really belong in main. And so you're never supposed to work in main, you're supposed to work in your own branch. And so what are you gonna do? Typically what I've done in the past, before I knew this, I would take all the changes that I made, I would move the files physically on my desktop, and then delete the repo entirely, go out back to GitHub, clone, and then move it back in, right? Which is a really, really crappy way of doing it. So cherry picking to the rescue, essentially what you're gonna do is you're gonna go in your main, you're gonna look at the commit that you've done in your main branch. You're gonna go out and check out where you're supposed to actually commit that, and you're gonna essentially use the git cherry pick command with the commit hash to basically say, I'm gonna take it from my main branch and then move it over to my feature branch. And then that still exists, at this point it exists in two places. Then what I could do is I go back to my main branch and say, I'm getting rid of this commit, and I've cleaned up all my commits in my main, and now I have it where it belongs. Does that make sense? Okay, so let's look at it real quick, and then here. So git log --1 line, I look at my commits here. I made a commit. Clearly my second from the top needs to, actually I'm going through and creating a new commit. I don't realize that I'm creating a new file. I don't realize that I'm working in main, and I'm committing to that. I panic because that's not going to be approved if I do a pull request. So I'm going to go ahead and simply say git logged. Notice that this here is supposed to be in my feature branch. It's not supposed to be in my main. So I can simply go over to my feature branch, git checkout feature. I need to learn how to type faster. I've noticed by doing these presentations. Git checkout feature, and now I can go git cherry pick. I know the hash from the main is this right here, so I can grab that hash key, paste it, and you're all ready. Moved it here. Now I can go back to my main and just basically reset the head to move it back to this latest, and which would get rid of that commit in main. So you can see how really useful these tools are when you're working in production. But with that, I talk about Bash.
We'll talk about Bash. Go ahead and slide behind here. Perfect. So Bash is one of those things that we thought was eventually going to go away. But the more that we work in network automation, the more that we know that it's a very important tool in our tool belt to have. If we've made Docker files, if we've done Docker images, you may be writing something in Docker syntax, but if you notice there on the far right side, all of that is imperative language from the shell. We're doing updates. We may be copying files, touching files, moving directories, building things. Even if we're executing certain Python functions or Go functions, you're still executing them through the Bash shell. On the bottom, we have GNU Make, which is from the old days when we would pull down something from source code, and we would do a make clean, and then the build. We use GNU Make to do some simple automation with that. And then finally, on your right-hand side is an example of a CI/CD function. So if we're using GitLab CI, or if we're using GitHub Actions, or we're using any other CI/CD tool out there, most of the time we're building these things, but we're building them using Bash. So it's YAML formatted. So we may have some actions and syntax that is unique to that build server, but we're still executing these Bash commands to make it. I call that YAML wrapped Bash because we're still, like you can see, this is an example, we're still doing curl commands, we're still installing certain processes from our repos and things, we're still using Bash. So this is what's old is new again. Bash is old, it's been around for 36 years, and it will always be there as far as I can tell. I do a lot of things with our GitHub repositories using Bash, and I used this book when I was in university. I gathered this book for a computer science class, Unix shell programming. I was in university probably 15, 18 years ago. I use this book more in my day-to-day than I have any other book in my library. It covers Bourne shell, so the SH, but I still have this tabbed, and I didn't bring it with me because I forgot it, but I have it tabbed with all the different sections and things that I use. So not an endorsement, but this is a very good book if you're into, if you need to learn some Bash. like I said, it's 36 years old. Everything that we enter at the Linux CLI, so when we use a Linux shell, can become part of a script or a pipeline. It may involve some special syntax. We may be using YAML to define our features or our steps inside of that. But it's still just imperative language that we're putting inside of that YAML file. We're still doing apt-gets. We're still doing CDs. We're still doing the things at the shell, even in those complex scripts. And they can still execute higher order processes like Python, Ansible, Terraform. But if we call Ansible-playbook with some string there, that's still invoked from the shell. So you still have to be at least vaguely aware of how shells operate. More importantly, as we chain things together with like the double ampersand, the double and sign, we need to know order of executions, or maybe we need to pass variables into those things. How does the shell interpret those to make them work so they actually perform the functions that we need to? And everything is just running inside of a Linux container. So we'll touch on containers in a little bit, but all of these GitLab, CI, GitHub Actions, etc., they are just running in some sort of Linux container. So you need to understand Linux. To understand Linux, you need to know the shell, and those two things together will help you understand our CI/CD pipelines. So again, it's 36 years old, but it's still driving most of our automated functions that we deal with today. For a practical application, Bash can build locally, and this is something that I use for a lab that I built, or that Kareem and I built for Cisco Live US. But this is just a Docker container. It's running inside of Alpine Linux, but you can see it's doing it's gathering things. It's doing an APK. I have some shell commands that are running there to give me the right output from the way that my PS1 looks in my shell prompts. I'm downloading things from APKs. I'm installing different pieces. It may be a Docker file, yes, but it's doing Bash things in the background. Bash also builds in the cloud. So this is an example of something that we use when we talk about integration manager. For all of our Cisco U tutorials, I'm the integration manager. I handle every tutorial that is written on Cisco U to get moved into our production learning management system. I have this pipeline that is built that takes in the markdown, converts it to install some software inside of the Docker container, converts markdown to a special proprietary XML for our learning management system, performs some validation and linting, and then creates messages inside of a GitHub pull request to say where any errors are, if they exist, or if it transferred successfully. So I have a lot of different things that are going on there, and I'll try to walk through them as it goes through. But you can see it's gathering a container. So it's using Ubuntu latest. It's waiting for a hosted container. It grabs the repository. It's going to install some things using apt-get. It's going to install some binaries using curl. It's going to convert these things, and you can see I have these things that are pushing GitHub commit messages to the PR. But again, that declaration is just 130-ish lines of Bash. That's all it's doing. So even though it's in the cloud, even though it's native, it's modern, it's new, it's cloud, it's still running Bash in the background. And finally, when I die, I don't care about my browser history being cleared. I don't care what people know that I was online looking at. But because I do some really ugly things with Bash, Kareem, clear my dev folder. All right, and over to you for some Vault.
Okay, so the next tool that I think everybody should know and learn, or at least a variation of it, is Vault. So as you look at, so what we've been talking to you about, and really in the real world, is Cisco has a bunch of APIs, right? You're going to leverage all these APIs to build some type of automation, and this is your automation layer. We'll use this example, for instance. You're building an automation. Your customer has Catalyst Center, Meraki. Maybe you're automating your on-prem and your cloud-managed devices. It's a deployment. Maybe you need to push some messages as you're deploying or you're troubleshooting to WebEx using those APIs. And potentially you have some type of Grafana dashboard running, monitoring the device temperature, for instance, and how hot they're running. Or maybe you're planning on deploying some AI infrastructure and you need some vector database to be deployed. And you need to automate all of that and have some type of script on top of it. You could use Ansible, Python, whatever it is, we don't really care. The one thing that you are gonna have to do is you're gonna have to keep track of every single API token, SSH key, And then different devices have different authentication methods. You got to use a basic auth with Catalyst Center versus an authorization bearer for Meraki and as well as WebEx APIs. So what I'm trying to get at is you're going to have to keep track of all of this. And I can't tell you how many times I've lost tokens. I had to go back into the device in the dashboard and regenerate a token. Some of us might not have access, the right privileges to the platforms to be able to generate a token, because typically that's given by your admin. And so what ends up happening is what we call a secret sprawl. And so don't be like Quinn and write all your tokens on a piece of napkin in the back of your laptop. And so this is where Vault comes in play. HashiVault is a really great open source tool that allows you to basically store all your secrets. And so it can act as your single source of truth to anything. You can store your API tokens, SSH keys, basic auth, your DB credentials. But what's great about all of this is two things. First of all, Vault itself has the ability to basically create ACL rules for your secrets. And so you could say application 1 is only allowed to access the DNA Center or the Catalyst Center secrets as well as the Meraki secrets, versus application 2 could only, which is a container that just gets fired off to post a message to a WebEx room, has only access to the WebEx APIs token, right? And so with the ACL, you can essentially grant and deny access to the application. So if your application gets compromised, right, you can simply say, go to your Vault instance and say, application 1, I'm going to kill that ACL rule, and it loses access to everything that I have in my infrastructure. And then what's great about Vault itself is it has APIs, and it has a really cool SDK. So if we look at this integration that we were talking about, you can simply deploy Vault, whether you have it on-prem in your infrastructure or you use a deployment in AWS or the cloud somewhere. You have Vault running. Your application goes out to Vault to say, hey, give me credentials. Vault comes back via the API, says, great, and then you can start accessing your devices and build your automation. And so real quickly here, I'm going to give you just a snippet of how it works, and all of that is available for you as a Cisco U tutorial to try out. You simply go out and you leverage the HVAC, which is Vault's SDK. You're bringing into the fold of your automation script. You instantiate an instance of that SDK, and you say, here's my Vault server. These are my unsealed client token, and these are all terms that we'll walk you through as part of that tutorial. And then you go in, think of a Vault as if you have a physical Vault at home. The first thing to get into it, you got to unseal it, right? So you got to unseal that Vault to be able to access your secrets. This is a simple example here of calling the DNA Center or the Catalyst Center APIs to say, pull the secret, the API token from my Vault instance. It's as simple as saying client.secrets followed by the version of the secret that you're using. And then you can simply go out and make that API call to your DNA Center. And that would essentially pull the list of devices from DNet. It's a really great tool to have in your tool belt. Learn it, know how it works, introduce it in your automation lifecycle, because it's going to save you a lot of headache and time.
Okay. And I'm going to speak pretty fast here because I've got two topics that I want to touch on. One is infrastructure as code. We've talked about this a lot in a single context, so a single instance. I've gone and presented at Cisco Live to talk about using Ansible for compliance, or how to use Ansible for the EN auto. I've talked about how to get started with Terraform and some of the HCL basics that have gone on. All of these are available in QR codes at the end of the presentation. But I generally talk about automation like this. So we have APIs. We start with Ansible. We start learning how to manipulate and automate our networks in certain ways. Then we say maybe we want to move on to something different like Python or Go. We put all that, like Kareem said, we put that in a VCS, we put that into GitHub or GitLab, and we try to build a pipeline. A pipeline is just something we use to automate our network. We realize how difficult that is because someone may write Python a certain way and expect certain variables. I may write it differently. Some may write Go, some may write Node. It becomes very difficult to integrate very cross-domain things, plus on top of keeping on top of the SDKs. So then you may realize that this is really difficult, and then you go back to Ansible or Terraform because it's so much easier and it levels the playing field. Everything is the same. I write Terraform for AWS the same way I write Terraform for Azure or Terraform for Catalyst Center. It all looks the same, and I only need to know Terraform. I don't need to know the CDK. I don't need to know the DNA Center SDK. I don't need to know these ins and outs. I write in Terraform, and I do it once. So infrastructure as code is great for cloud. This is an example I've used before for presentations with the ENCC, our enterprise cloud connectivity exam, where I've built a VPN in Azure to connect to an on-prem resource. This is available as a tutorial inside of Cisco U, but I use Terraform to apply this. It creates all of the things that are needed, the virtual network, the VPN concentrator, the connections, all of the IPsec things. It will do all of that using Terraform, and it may take a while. This is a very sped up version. It takes about 30 minutes to build, but I can do that using Terraform very quickly. If I want to build a VPN endpoint between Azure and AWS, I can do that as well using the same kind of connectivity or tool set. But did you know that you can go backwards? So this is a tutorial that I wrote for our Cisco U Spotlight talking about Terraformer and Azure Export for Terraform. Both of those tools allow you to take what exists inside of your cloud infrastructure that you may have generated using Click. You know, I've created something inside of AWS using the mouse and keyboard. I can extract that configuration and turn that into Terraform HCL. So I can go backwards and forwards using one of those two tools. Terraformer is cloud agnostic. Azure Export for Terraform is obviously for Azure only, but it works very well in order to demonstrate. And this is an example where I had that same VPN that was configured, and I use Azure Export for Terraform to gather that configuration and turn that into HCL. So even if I've lost that Terraform, which I have, I've used this tool to recover that because that was still running inside of the cloud. Very handy tool set there. Infrastructure as code enables easier pipelines. So I have a link to the previous DevNet session where I've used a tool called Atlantis to create infrastructure as code pipeline without having to build any of that YAML wrapped bash using Atlantis. The link that I'll show there, it puts everything as a GitHub pull request message. I've also done presentations on enabling version control systemless pipelines. So this is using console, the Hashi stack, Console and Terraform, to automate changes. Someone deploys an application, the infrastructure sees that and automatically configures itself so I don't have to worry about any new configuration. It's done automatically just by using Console and Terraform. And again, I have links for that up at the end as well. Finally, I'll talk about containers, and I know I'm moving pretty quickly. Containers, I have a session on Cisco U that talks about what makes containers unique. Basically, on the left side, we have containers where we have socket access to our kernel, the core of our system, and we have applications that ride on top of that as containers. They're very fast to instantiate, they spin up very quickly, and we can use them to separate our applications, which is different than hypervisors like VMware, where we have this isolation, but we run full operating system stacks and applications on top of that. A little bit more secure, but they're much larger and they're much longer to instantiate. But I talk about containers a lot by saying I can package everything up in a container and use that for development. If you've dealt with Python or Ansible, they're very version specific. Instead of having to worry about managing that, put it in a container. Use the container for automation. I can have an Ansible 2.10, 2.11, 2.12, 2.13 container and roll through those very quickly. But containers can do both. If you've heard about functions, cloud functions using Google Cloud Run, AWS Lambda, think of those as an application that runs at a trigger, does one thing, and then removes itself. So an example would be leveling up a container in the cloud. We have a container running some Python in AWS Lambda, reaches out to Meraki Cloud and gathers our device status. It receives that and then posts a message to WebEx, to a room. We can tie that to API gateways. So I can hit an API to have it pull that status whenever I want, or I can use Event Bridge and have it scheduled. Say when I walk in the morning at 9, and before I leave at 4:30, automatically run those scripts and have them being sent to WebEx, so I know when I show up and before I leave what the status of my network is being. But that function, when it's triggered by either Event Bridge or the API gateway, runs its function, sends its message, and then removes itself. So I don't have to have a persistent application. Wrapping it all up, we can see how this is all interconnected. But what I wanted to talk about mostly is we've been talking about these things for a while. This will take you to the Cisco Live on-demand search. These are the sessions that cover everything that we've talked about in the past with recordings and slides. So I'll leave that up for a second. There's a second slide that I want to get to, and you can find me afterwards if you need these. These are hands-on tutorials. So using the Cisco U platform, these QR codes will take you to some of the hands-on tutorials we've talked about to get you hands-on using these automation tools.
And with that, we've put all of that together to kind of give you an idea of what you're going to be using out there in the real world. And we've given you the resources. We're here all week. So if you have any questions or you'd like to discuss a project that you're working on from an automation perspective, we're happy to spend some time with you. Also, we have a promo for everybody that's here this week. Our testing center is offering 75% off our certification exams. So if you're thinking about taking a test, or maybe you're after your DevNet expert, head over to upstairs and get our certification. Get signed up to take a certification exam. And with that, we thank you for your time, and hopefully this was beneficial to all of you. Thank you.